There we go. Almost. And okay, so let's start. So ladies and gentlemen, welcome to this week's Monsoon seminar. Our speaker this week is Coralie Zorzi from the University of Bordeaux, and she's going to be talking to us about the monsoon in India, in South Asia, since the last glacial maximum. Coralie did her bachelor's degree in Bordeaux, and then she went to Canada, to Montreal, to do her PhD, where she finished in, I think it's 2019, and now she's a postdoc back in Bordeaux. Without further ado, I shall hand over to her now. As usual, if you could put your questions in the chat, I'll ask you to give the questions at the end of the talk. So thank you very much. So Coralie, please take it away.
Okay.
I can see that. That's great.
And you can see the mouse too?
I can, yes.
Okay. So I will just move that here. Okay. So hello. So thank you, Peter, for this introduction. Good morning or good afternoon, everyone, depending on where you are following this presentation. Thank you very much to be with me online to hear and to discuss about the Indian vegetation and the monsoon during the next hour. So today I would like to share with you new findings from the postdoctoral contracts that I led at the University of Bordeaux in January 2019, first as a research and teaching assistant, and then by getting a postdoctoral fellowship from IODP France. So if it's working, yes, okay. So after a short introduction on the Indian monsoon, which is the star of this presentation, I'm going to present the studies that I recently published in Geophysical Research Letters, which was titled as the seminar of today. So when Eastern India oscillated between desert versus savanna-dominated vegetation. This work was supported by the École pratique des hautes études and involved international collaborations between France, US, Portugal, and India. And at the end of the presentation, I will conclude by giving a brief summary of the goals of the project that I'm actually leading in France, the one funded by IODP France. The project is named ARID for response of the Indian vegetation and monsoon change during three contrasting glacial periods, the MIS 6, 10, and 14. So I would like to start the seminar by introducing very quickly the Indian monsoon system. Even if it's a monsoon seminar, I think it's always good to have a fresh reminder of the monsoon system that we are going to investigate during the talk. So the Indian summer monsoon occurs between June and September, when the strong insolation of the summer months reinforce the atmospheric pressure and temperature gradients between the Indian Ocean and the Asian continent, leading to generate seasonal or warm and moist wind in India. In opposite, during winter months, so from December to February, when the temperature and pressure gradient reverse due to the low insolation, the dry and cold wind cross over India from the East Asian continent to the Arabian Sea. And this process corresponds to the Indian winter monsoon. So in India, the summer monsoon constitutes the main climate driver, bringing more than 80% of the annual rainfall. And it's why determining what controls the regional and seasonal precipitation pattern is currently among the biggest scientific issues in this region for the future. In fact, the Indian summer monsoon appears particularly sensitive to ongoing climate change, and its variability could have been a threat to freshwater availability and as well to the sustainable agriculture in India in the near future. And despite intensification of the monsoon rainfall suggested by numerical models, severe droughts were recently recorded in India, having dramatic consequences for the population and the economy of the country. If the situation has today deep influence on the daily life of billions of people, it was also the case in the past, when the Indian monsoon collapse have led to severe famines that were unfavorable to the long-term stability of the civilization, such as, for example, the Harappan civilization in northwestern India. In addition, uncertainties of the monsoon rainfall will have also a major impact on the future of the Indian forest and vegetation. And for this presentation, I will focus more specially on the savannah ecosystem. It's ecosystem, so it's on the title. So as you see on the vegetation map here, the tropical savannah, represented by the light yellow orange color, depending on your screens, cover a large region in the Indian Peninsula. And this vegetation is a mixed tree grass system characterized by continuous herb layers with discontinuous tree canopy. So the herb layers is usually dominated by C4 grasses that use the C4 photosynthetic pathway to fix the carbon, whereas trees mostly use the C3 pathway. This ecosystem, so the tropical savannah, is extremely sensitive to changes affecting the hydrological cycle, and its expansion or reductions seems to have a major impact on the regional fire activities and on the global atmospheric CO2 concentration. So in order to better understand environmental changes and climatic mechanisms leading to catastrophic weak monsoon intervals, my postdoctoral work deals with glacial periods during which the tropical hydrological cycle show particularly strong and rapid reductions at orbital and millennial time scale. So the work that I'm going to present focus on the last glacial period, so from 80 to 20,000 years ago, which includes the marine isotopic stage 4, 3, and 2. This period was characterized by non-analogous boundary conditions. So the northern hemisphere was covered by major regional ice sheets. Insolation remained low and showed distinctive astronomical configuration as represented here by the variations of the obliquity and the precession. And I would like to mention that here and during the rest of my presentation, the scale of the precession will be reversed. So it's the dark line, the precession curve, and it means that this is the precession maximum and this is a precession minimum. But I will repeat that later during the presentation. So forcing controlling the Indian monsoon remain strongly controversial and are still debated. At orbital scale, some authors, such as Kataya and collaborators, who perform delta weighting analysis on speleotene from B2 cave, so in northern India, suggested that during the late Pleistocene, the Indian summer monsoon is directly driven by precessions-induced changes in the northern hemisphere summer insolation. In opposite, others, such as Clements and colleagues, acknowledge the influence of other mechanisms and the importance of feedback teleconnection, such as, for example, obliquity, which may have affecting the Indian rainfall by the presence of a low latitude interhemispheric insolation gradient, highlighting therefore the importance of the South Hemisphere in the Indian monsoon variability. Another debate lies on the modulation of the tropical hydroclimatic events by astronomical forcing, such as a precession in controlling the amplitude of the monsoon rainfall at millennial and centennial scale. And even if the rapid climatic variability of the Indian summer monsoon has already been recorded in many records, this purpose remains largely unexplored. So in order to test this hypothesis and to explore the impact of the astronomical forcing on the modulation of the rapid events, our study focuses on the last glacial period, which first interestingly present a maximum of obliquity in phase with a maximum of precession, and then punctuated by rapid climatic events such as the Greenland stadials and interstadials. And the study that I'm presenting aims at answering to the following question: is the Indian summer monsoon impacted by the northern hemisphere or the southern hemisphere during the last glacial periods? So to answer to this question, I investigated marine sediments from the high ODP site U1446, which is located at the exit of the Manadi River, which is one of the biggest rivers on the eastern Indian Peninsula. So this site was drilled during the high ODP expedition 353, the Indian monsoon rainfall, and appear very strategic to reconstruct the Indian monsoon variation in the past, because it is situated in the famous core monsoon zone, which is an area considered as especially representative of the monsoon rainfall in India. So the age depth model of the study section was established using 12 control points, including 4 C14 dates, the top and the bottom of the Toba ash layer, and 2 delta weighting benthic dates. In addition, in order to better constrain the age model, I also add 4 tie points correlating structure in the millennial scale variability expressed at site U1446 by the calcium content in pink and the pollen record here in green and in brown, to the well-dated delta 018 from the B2 cave record in blue on the graph. Only because it was very difficult to obtain good C14 dates beyond 30,000 years. So there were 4 main assumptions sustaining this correlation. First, Nielsen Kerr and collaborators in 2022 has already shown that proxy record of site U1446 and B2 cave speleothem shows similar millennial to centennial fluctuation of the Indian monsoon variation during the marine isotopic stage 5. Then age model of the last glacial period in B2 cave is very robust because it's combined 57 thorium dates. Third, chronology of the rapid climatic variability in B2 cave is well established in contrast to other glacial speleothem. For example, the Yulu cave record here in gray, we show an uncertain correlation with the Greenland chronostratigraphy during the marine isotopic stage 3. And finally, and the main, the more obvious reason, B2 cave record is the closest Indian speleothem of the site U1446, covering the entire glacial periods. Therefore, I selected tie points associated to exceptional monsoon events because they are easily recognizable in the context of weak monsoon interval as during the last glacial periods. So at site U1446, they are identified by the rapid drop of the carbonate content, which is interpreted as the reflex of the drop of the marine productivity due to a strong stratifications induced by massive monsoon runoff. And the scale is also reversed for the calcium, so the drop are on the top. And this strong calcium decrease occur in good agreements with the large increase of the tropical trees percentage. And we will see that later on the top, which are interpreted and considered as a marker of heavy rainfall. So this good correlation allows the determination of 4 major moist events that can be aligned to the 4 most events recorded by the negative excursion of the delta weighting in B2 cave, which were previously identified and associated by Kataya and collaborator to the Dansgaard-Oshger warming events 8, 12, 4, and 17. So I performed pollen analysis on 147 samples from the HIODP sat U1446 in the time interval covering the last glacial period. The analysis of the pollen grains and spore was led in Bordeaux and consists in the counting at the microscope of at least 150 pollen grains per sample, which is a relatively time-consuming activity because I need at least 2 days for counting one sample only. But the pollen grains are very cute, so it's not a big deal. Yes, so the pollen record allows the reconstruction of the vegetation changes in the Manadi catchment, which are strongly controlled by the Indian summer monsoon variations. So before showing the results, I would like to introduce the different ecological groups found in India. So this map shows the potential modern vegetation distribution. So it corresponds to the distribution of the vegetation if there was no human disturbance. So vegetation which is exclusively controlled by natural forcing. There are 3 main ecological groups in the Manadi catchment: the dry deciduous forest, also named the tropical savanna, the moist deciduous forest, and the semi-evergreen forest. And distribution of this group is mostly driven by an humidity gradient increasing from the tropical savanna to the semi-evergreen forest. Of course, other types of vegetation are found in India. For example, the tropical wet evergreen forest in the Western Ghats, or the mangrove on the coastal area, which is represented by the purple color on the map. So there is few patch of mangrove today in the Manadi catchment, but this ecological group is mainly affected by edaphic factor and is not directly controlled by the rainfall. I would like to draw your attention on the vegetation surrounding the Thar Desert in northwestern India, which appear particularly important to interpret the pollen assemblages found during the last glacial periods. So in this area, there is a succession of vegetation also responding to an humidity gradient from the desert vegetation in the desert itself to the tropical savanna, passing through the semi-arid steppe. And composition of this semi-arid steppe also depends on subtle moisture changes, while some herbs as Artemisia grew up in moist environments. Other prefer the drier environment. It is the case of the semi-arid taxa as Ephedra or Amarantaceae. And while still others, such as the grassland, appear to be more widely distributed. So here are the results. The diagrams show the percentages of the taxa occurring at least in 5 samples after a 2% filtration with the air package Paleomess. So the taxa are classified according to their ecological affinities as the mangrove and associates in blue, the tropical arboreal taxa in dark green, and which is also called tropical trees for the rest of the presentation. The arid taxa are represented in orange and includes Ephedra and Amarantaceae. And I show the herbaceous taxa, so the herbs, in light green. I also show, yes, the percentage of spore, hano, and broken taxa. And I would like to draw your attention on the percentage of broken or corroded taxa, which are very low, attesting the high quality and good preservation of the pollen grains at site U1446. And on the right, I also show the cluster analysis, which help in the delineation of the main pollen zone and interpretation of the pollen diagram. So before going to the description of the pollen diagram, I would like to show the result of the principal component analysis that I perform on the same dataset used to plot the synthetic pollen diagram that I show on the previous slide. So the statistical analysis indicates that the first 2 axes capture 34% of the total variance. The first axis is distinguished by the contrast between the dry taxa, such as the arid Amarantaceae with negative score, and the humid taxa with positive score, which include the tropical trees as Combretaceae, Glaucidium, Malotus, Olea paniculata, or Haldina, as well Rhizophoraceae, and the moist herb Artemisia and Cyperaceae. So considering the ecological affinities of the taxa expansion on rainfall, humidity appears as the main environmental factor controlling the sample's dispersion on this axis. And it's why I use the axis 1 sample scores as humidity index to record past hydrological changes in India during the last glacial period. So this is the final result. On the top, there is in green the percentages of the tropical trees, including both the dry and the moist components. The gray or dark line on the screen represents the humidity index, which closely and lovely follow the forest percentage. The other curve corresponds to the pollen percentages of the distinctive herbs, which grow up in the semi-arid steppe, including the moist Artemisia, the widely distributed Poaceae, so it's a grassland, and the semi-arid taxa in brown. So at orbital scale, our records show maximum in monsoon rainfall during the early MIS3, as suggested by the strongest percentage of the tropical trees and the moist herb Artemisia, as well by the highest values of the humidity index. In contrast, the driest conditions are recorded at orbital scale during the last glacial maximum by the collapse of the tropical trees and a strong increase of the grassland. Abrupt vegetation and thus monsoon changes are superimposed to the orbital variation. So here you can see the dry events, which are identified by major increase of the semi-arid taxa. Most of these dry events are associated with Greenland stadioles, and more specifically with the cooling episode linked to the highest rafting events in the North Atlantic, namely the enriched stadioles. So the enriched stadial 2, 3, 4, 5, 6, and 7, except for one of the dry events which occur during the interstadial transition 19. So the particular expansion of the semi-arid taxa instead of the grassland suggests that drier conditions occur in India during the enriched stadial and the interstadial transition 19 than during the last glacial maximum. In addition, the proportion of the semi-arid taxa also reflects the distinctive level of dryness during the identified events. In her record, the enriched 5 stand out by the largest reduction in humidity, which is also very pronounced during the enriched 2 and the interstadial transition 19. In contrast, less intense dry conditions are recorded during the enriched 6 here and 3, and moderate dryness events occur in India during the enriched 4. So, at orbital scale, we observe a disconnection between the summer insolation and the monsoon variability. So the monsoon maximum does not appear in phase with the peak of insolation, and the monsoon minimum here lag behind the insolation minimum by several thousand here. But if we deconvolute the insolation signal, the monsoon maximum occurs during a specific astronomical configuration, phasing an obliquity maximum here in purple with a precession maximum here in gray. So as I said in introduction, the scale of the precession is reversed. So this observation reveals that the monsoon variability appears disconnected from the precession forcing, because a low precession, such as recording during the early MIS3, will lead to a reduction of the seasonal thermic contrast in India and thus of the monsoon rainfall. Therefore, our study records a dominant response of the Indian summer monsoon to the obliquity forcing during the last glacial period, and response of the monsoon to the obliquity disagree with the speleothen record from B2K. And in turn, it supports the importance of the interhemispheric gradient on the monsoon variability, as already suggested by Clements and colleagues for the middle and late Pleistocene. In fact, several numerical simulations suggested that obliquity is a key controlling factor in modulating the Hadley circulation, which strongly affects the tropical region. So strong obliquity will have increased the pressure contrast between the southern and the northern Indian Oceans, thereby sustaining a northwest position of the high TCZ, so the intertropical convergence zone in India, and a reinforcement of the Somali jet, which consequently increase the heat and the moisture supplied from the southern hemisphere to India. So this mechanism is now clearly supported by data. On one side, a record here from the Arabian Sea showing an intensification of the Somali upwelling during the early MIS3, and on the other side, by our data, showing an increase of the monsoon rainfall in eastern India. So the monsoon minimum occurs during the last glacial maximum, when the ice volume reaches its maximum. So our record agrees with numerical simulations performed during this time interval, and suggesting that a major increase of the volume of the ice sheets will have contracted the Hadley cell, shifting southwards the high TCZ in India, and thus reducing the amount of humidity supply to India. In addition, this atmospheric configuration will have favor stronger westerlies in the Arabian Sea, conveying the temperature anomaly from the high to the low latitudes, and that results in the cooler regionally system in the Arabian Sea and reduce moisture supply into India, and thus a reduction of the monsoon rainfall. So now, regarding the millennial scale variability, models suggest that a contraction of the Hadley circulation also occurs during the episode of the massive iceberg discharge in the North Atlantic. So as during the last glacial maximum, this mechanism supports a reduction of the interhemispheric heat transport, a southward shift of the high TCZ, and an increase in the westerlies over the Arabian Sea, which has already been reported here by the drop of the aluminium content. Despite the moderate cooling recorded in the North Atlantic Ocean and the mute signal of the positive westerlies anomaly in the Arabian Sea, the dry events occurring at the interstadial stadial transition 19 appear synchronous to the large explosive eruption of the Toba volcano, which suggests that a large northern hemisphere volcanic eruption can generate a global southward shift of the ITCZ and reduce musonal rainfall in India by increasing the atmospheric aerosol concentration. And this mechanism, this hypothesis was already proposed in the literature, but our record provide support this hypothesis. Our pollen record reveals that drier conditions prevail in India during the enriched stadial, comparing to the last glacial maximum, which suggests that other mechanisms need to be involved to explain the large drops in the monsoon rainfall. One of these mechanisms may consist in the slowdown of the hammock circulation recorded during the enriched stadials, which is likely an additional process cooling the Arabian Sea and reinforcing weak monsoon condition in India. But it seems that there is no direct relationship between the amplitude of the Indian events and the magnitude of the hammock slowdown. For example, the enriched 4 and 5 are characterized here and here by the similar reduction in hammock, whereas the enriched 5 is associated with the driest condition in India. So the different level of dryness of the enriched events, which appear a contrasting feature with the B2K record that you can see here, which show similar drop of the monsoon during all the events, are not directly modulated by the amplitude of the hammock changes. But our vegetation record that shows that the dry events occurring during the interstadial stadial transition 19, the enriched 5 and the enriched 2 are exceptionally well expressed by the major expansion of the arid taxa. And noticeably, they all occur associated with a precession maximum. So again, here the scale is reversed, which enables a reduction in the seasonal thermic contrast in India and thus of the monsoon rainfall. So we suggest that the orbital context, and more specifically a low precession, likely amplify the unfavorable monsoon condition initiated by oceanic and atmospheric reorganization related to the North Atlantic cooling events and the volcanic eruption. So the main finding of this study on the last glacial period there is a dominant response of the Indian summer monsoon to obliquity forcing by directly affecting the interhemispheric pressure and temperature gradients and remote control forcing during the last glacial periods. But even if a disconnection of the monsoon variability is recorded at orbital scale from the precession cycle, the millennial scale variability of the Indian monsoon appear directly modulated by astronomical context and more specifically by the precession. So now, what are the next steps of my research? So the project area that I'm currently leading at the University of Bordeaux aims at documenting the vegetation and monsoon changes in India during 3 glacial periods characterized by different boundary conditions. So namely the marine isotopic stage 6, 10, and 14. So the objective of this work is to better understand the drivers controlling the Indian summer monsoon during the glacial periods, which are commonly associated to a reduction of the hydrological cycle in India, as it was reported during the last glacial periods. But, and the figure appear very small, but taking a look to the long-term record of the Indian monsoon variability, as for example, the Delta D record from the IODP site 21446, published last year, I think by McGrath and collaborator, or the B2 cave record from northern India. It's obvious that the monsoon rainfall varies in amplitude during the different glacial period, shown in white in the figure. So, for example, a strong reduction of the precipitation is recorded during the marine isotopic stage 12. There was relatively strong precipitation, or moderate, we'll say, are recording during the early MIS 6 or 8. So that suggests that the monsoon variability seems different during each glacial period, which question on the recurrent pattern or punctual effects of the drivers proposed for the last glacial periods. So the first target of the ARID project is to identify the Indian summer monsoon sensitivity to changes in the external forcing to the Earth's climate system, so the orbital forcing, and other internal processes, including the ice volume and the CO2 concentration. So the main hypotheses that I would like to test are the following. The highest glacial rainfall occur in response to the obliquity maximums by reinforcing the inter-hemispheric gradient, as I suggested for the early MIS3. The lowest precipitation are recorded when the global ice volume reach a maximum. And more specifically, I would like to document the potential direct connection between the amount of the ice volume and the precipitation in India during the different glacial maximum. And the last hypothesis is to test if the response of the Indian summer monsoon varies depending on the distribution of the ice sheet in the northern hemisphere due to their distinctive impact on the Hadley circulation. The second target of this project is to document the rapid environmental changes in India and to explore the drivers of the millennial scale monsoon variability, which remain very poorly constrained beyond the last glacial cycle. So here the main hypotheses to test are that the precession modulates the Indian summer monsoon decrease, the rapid drops of the Indian summer monsoon, and that the rapid variability of the Indian summer monsoon is controlled maybe by other mechanisms, why not impacted by the southern hemisphere. So to do that, I'm focusing on 3 specific glacial intervals that I will compare with the last glacial maximum, of course. So the MIS 6 is characterized by a strong increase of the ice sheet in Eurasia in comparison to the last glacial maximum. The MIS 10 is associated with limited ice sheet expansion in the northern hemisphere, but relatively cool condition in the south hemisphere. And the MIS 14 is considered as a warm glacial period, almost a cold interglacial. So for the methodology, I'm also performing palynological analysis at site 21446, so including the pollen grains and spore to reconstruct past vegetation and rainfall, but also the dinocysts here, which are the rare way to explore through the same analysis the interaction of the land, atmosphere, ocean system without chronological ambiguities. So the dinocysts are robust proxy for reconstructing the sea surface condition, such as the marine productivity, the salinity, temperature. And I hope they may provide precious information on the stratification of the water column during the intense monsoon rainfall intervals. So the analyses are on progress. I will finish in October, so maybe I can tell you another story about the Indian monsoon relatively soon, I hope. And a last word before the question, if people are still alive. We submitted a session at INQUA, which will be held in Roma next July. So this session invites contribution for all the regional monsoon area, including Africa, South Asia, East Asia, Australia, Indonesia, America, based on proxy record, climate model and data model comparison during the Pliocene, the Pleistocene, and at different time scale. So from orbital to millennial and centennial time scale. So the idea was to gather people from the data and the modeling community. So everyone is very welcome to submit an abstract. The deadline for the abstract submission and financial support is the 1st of November. So yes, please join us. Thank you very much for listening, and I will be pleased to respond to the question for the online participants. Thank you.
Thank you very much. Thank you very much. Let me see if we have any questions. Yes, we have a question from Ed Hathorn. Ed, do you want to unmute yourself and ask it yourself?
Yeah, can you hear me?
Yes.
You can see me? No? Okay.
Yes.
Thanks, Coralie. That was really nice. I got a question about the mangroves, and I wondered if the mangrove pollen follows more changes in sea level during the last glacial, or if it follows the humidity.
So
and maybe what that would mean for trapping of sediment or not.
Okay, so during the last glacial period, there is very few amount of pollen, mangrove pollen grains. But I guess I know that you know that we have other people, as Charlotte Clément, a PhD student at Bordeaux, and Dulce Oliveira, a postdoc researcher in Portugal, who are working on interglacial periods at this site. So they do this kind of analysis, and clearly, if we make a nice graph with all the results, including glacial and interglacial intervals, we can see that the mangrove percentage increased during interglacial. So it could be a good proxy to track the sea level. But the point with the mangrove, it's a bit tricky because it's both impacted by the amount of humidity and as well by the sea level. So it's always a bit complicated to distinguish which effect is predominant. So it could be nice to plot the data together and to see in details. But I believe that we can do something with the mangrove to track the sea level changes.
Yeah, so I mean, I guess the stage 3 strong monsoon was just as strong as the Holocene, really, in a lot of records. I mean, you also see this in the stuff from the Bay of Bengal, like from the Sona Cruz, there's a Lauterbach paper in paleoceanography, and there's also the Wang paper was in PNAS last year, where they really should show exactly the same sort of stage 3, stage 4, centered around 60,000 years ago, strong monsoon. But then if there's not as much mangroves, then
and
the sea level thing more than a monsoon strength.
Here, the stage 3, the maximum of the monsoon is this gray band here, and you see that there is no mini mangrove because I think the sea level is too low.
Okay, thank you.
Tara Janelle has a question too. Do you want to ask your question, Tara?
Sure. Hi, Coralie. Thanks.
Sure.
Excellent talk. Excuse me if I missed this earlier when you were just describing actually this plot right here a little bit earlier. But I was wondering if you found any evidence, or maybe colleagues that you were working with on this core found evidence for burn events like charcoal that could also give you either an indirect or direct constraint on humidity during these dry periods.
Actually, it's something that I would love to do in the lab. We work, I think you know Anne-Laure Dagneau, so we work on the same lab. The microscope proofs and her office are front to front. So in the slide at the microscope, I distinguish micro charcoal. But I can't tell you which one. I know there is the elongated one, the small one, or something like that. So that I would like to do maybe one day in the future, if Anne-Laure is interested in, of course, it's to do the micro charcoal on this site. And I think she did some analysis for the Holocene.
Ah, interesting. Okay,
but
cool.
It's mostly related to the PhD of Charlotte Clément. And I think she produced the data, but I'm not certain that she started to really work on. Maybe one day, but it's something that I would like to do because it's obvious that we have micro charcoal on this site.
Yeah, I was just curious because
if it's a good one or not, and I was thinking maybe just to put a note, a lot of micro charcoal, no many macro charcoal, something like that, you know, on my side.
Even a relative index would be helpful.
It's really hard to say because sometimes the material is more or less concentrated because I would like to increase the count of my samples. So I'm not sure that it's really robust information, just my small notes on my notebook. But yes, it's something that we can do for sure.
Great, thank you.
So actually, I would like to ask a couple of questions. So you were emphasizing the role of precession on the monsoon in South Asia. Is that how does that compare with East Asia? Is that also on a precession control, or is that different? Yeah, it's a general. So, I have no idea.
I'm not so familiar with all the paper because there are many paper in East Asia, and apparently there is still a debate on the modulation of the rapid event, at least with the precession. And what I have in mind is that the debate is still open. Regarding the orbital variability, apparently, I don't want to say something wrong. So if someone, if I say something very bad, someone can just stop me. But I have the feeling that there are better response of the East Asian monsoon to precession forcing at orbital scale than the Indian monsoon, at least during the last glacial period. I'm not familiar with the interglacial periods in East Asian system.
And I have one more little question. So I was curious whether the dry or the wet phases, whether they were reflected in different mass accumulation rate at your site. I would expect maybe the wetter would result in more runoff, but you've also then got more vegetation, which might reduce erosion. Has anyone looked at that? Do you know how the erosion changes with your wet and dry phases?
At the millennial scale, you mean?
Yeah.
I'm certain that Clemens made some analysis on that.
Okay. I mean, it's fine. I mean,
I
that wasn't
didn't.
what you were looking at. So
I only calculate the concentration of the pollen grains on my report.
Okay.
And
yeah. I just
there is no major changes during, for example, the Henrik events and the moist interval.
Okay.
Neither during the last glacial maximum and the early MIS3.
And so your total record is what's just over 16 meters. Is that right?
Yes, it's from 8 to 16, so 8 meters in total.
Okay, and okay.
I know that the accumulation rates change during the Holocene and the MIS5. There is a huge change at this time.
Okay, thank you very much.
Probably due to the runoff and the erosion, of course.
Yeah, right. It wasn't clear to me that there was an obvious relationship. So So
yes, between the glacial and interglacial period, there is a major changes that we can, was estimated, but during the last glacial period itself, I think the sedimentary, because I did the model, so the sedimentation rates are more or less constant during the last glacial.
Okay.
I have the answer.
Right. Thank you. We have another question from Dorce Oliveira. Do you want to ask your question?
Good morning to all. And thank you, Coralie, for this amazing talk. It's not really a question, it's just more a curiosity.
Your micro, the sound is very bad.
Yes, you can read the question too, actually.
Yes, because I'm in the microscope room and maybe the internet
is
not good. Are you listening to me now?
Yes, it's better.
Yes?
Much better.
Okay, so you were very clear, so it's not the question, but a curiosity. So in this work, you are mainly focused on the forest contraction events in terms of millennial scale events and the events that were related to the Irish events. And I was thinking that maybe in the future, could it be also nice to explore the relationship and the response to the strong expansion forest events that can be related to the Dansgaard warming events? Actually, the ones that used in the age model seem to be very nice. And maybe it could be also something to explore in the future.
Yes, because it's true that I focus the presentation on the drop of the Indian monsoon on the Henrik events, but I record few Dansgaard events, and it's perfect because the slide is here. The problem with the moist is not a problem, yes, but it's a problem with the moist event in this record, I think, is the resolution that I have, which is not enough to record properly and statistically all the Dansgaard events. So I record the longest and the warmest, but the other, or sometimes I have only one slide can assess the existence of the other warm events, but it's not enough, I think, from my point of view, to describe them properly. But yes, it's something for sure. If I have the resolution, that I will investigate.
Okay, so we need a better resolution. Thank you, Coralie.
More samples.
Thank you.
Okay. Thank you very much. So I think we're at the end of our questions and the end of this presentation. And I would just encourage you to to come back next week. Catherine Vangeley from the University of Michigan will talk to us about mammalian faunas in Pakistan during the Miocene. And I hope you will join me either online or using your reaction buttons to show our appreciation to Coralie. And thank you very much for telling us about the South Asian monsoon. That's great.
Thank you. Thank you, everyone.
And I'll see some of you in a few minutes.
Yes, 20 minutes.
Yeah, sorry, more monsoons for some of us here for the rest of the day. Okay, thank you very much, everyone. Bye-bye for now.